The physical survivability of a hardened subterranean structure is calculated through the scaled distance formula, Z equals R divided by the cube root of W. Here, Z relates the physical standoff distance in meters, R, to the equivalent explosive mass in kilograms, W. Physical modeling reveals a threshold at a scaled distance of 0.55 meters per kilogram to the 1/3 power. At this specific proximity, the dynamic force begins to physically alter the crystalline rock structure. When a kinetic impact reaches this proximity, the primary structural threat shifts from surface air blast overpressure to direct geoseismic coupling through the rock mass. In 1951, the United States Army Corps of Engineers established the baseline engineering parameters for the Raven Rock Mountain Complex. The access portals were sealed by 34-ton, 13-inch thick solid steel hydraulic blast doors, engineered strictly to resist atmospheric thermonuclear air blasts. The primary defense mechanism is the geological shield itself. The facility sits beneath an overburden of greenstone and metabasalt, a dense formation possessing a uniaxial compressive strength of 220 to 280 megapascals. Defending against surface overpressure requires immense vertical scale, forcing the excavation 650 feet through solid rock to reach the main command vaults. But the geological density required to deflect a surface air blast creates a structural paradox. The dense rock mass acts as a highly efficient acoustic amplifier when subjected to low-frequency waves from ground-penetrating warheads. The geomechanical traits that make the facility resistant to a 1950s atmospheric threat provide the exact medium necessary for internal devastation from modern localized kinetic energy. This diagram plots the geoseismic shockwave attenuation formula. A of D equals A sub 0 times E to the negative alpha D. The variable alpha, at approximately 0.12 inverse meters, defines the specific shock dissipation coefficient of fractured pre-stressed granite. We can observe how explosive energy processes through these structures using empirical data from Project Cowboy's tests within deep spherical rock cavities. Seismic wave transfer into the surrounding environment is reduced by a factor of 100, provided the internal cavity pressure remains below 20% of the surrounding lithostatic overburden. Even when internal cavity pressure exceeds that lithostatic pressure by a factor of 6, the seismic wave transfer is still reduced by a factor of 20. Raven Rock's isolation architecture relies on this decoupling principle. The complex consists of 5 separate 3-story freestanding steel structures that rest entirely on heavy-duty 18-inch diameter steel coil springs. These springs work in tandem with hydraulic lateral shock absorbers to attenuate dynamic ground accelerations down to a limit of under 2 Gs. Geometrically decoupling the internal command structures from the host rock mass is the only physical defense against acoustic energy transfer. Understanding how kinetic energy degrades these complexes requires analyzing physical modeling tests on layered cemented tailings backfill, or LCTB. This chart models a transition heterogeneous structural interface during a blast, correlating volumetric strain, delta K, directly against the physical damage index, eta. Placing an explosive charge within a high-strength layer accelerates volumetric strain attenuation, moving delta K from 0.71 to 2.32. This spike correlates with a drop in the physical damage index, which falls from 13% down to under 8%. A continuous homogeneous structural interface yields different metrics. In a uniform strength setup, aligning the charge elevation with the interface decreases volumetric strain attenuation, causing delta K to fall from 2.54 to 1.32. Misaligning strength configurations inside these confined geometries reduces a facility's ability to dissipate volumetric blast strain. Additional tests attempted to mitigate downstream internal blast propagation using prefractal barriers modeled on Sierpinski carpets, intended to induce self-interfering shock fronts. The baseline parameters for these tests utilized 250 grams of PE4 explosive at scaled distances of 1.87, 2.24, and 2.99 meters per kilogram to the 1/3 power. Recent experimental testing of deflagration to detonation shock tubes loaded with dispersed particles revealed an aerodynamic deviation from theoretical models. The operational assumption held that introducing aluminum oxide and pure aluminum particles into the airflow would absorb and mitigate the blast overpressure. This vector field map displays the actual particle image velocimetry results. Instead of absorbing the force, the particle suspension decreased mitigation performance due to flame flow boundary layer drag. Adding mass to a confined shock path does not automatically attenuate the force. In the PIV tests, the resulting boundary layer drag maintained the high-pressure shock front that the particulates were intended to disrupt. Federal continuity of operations mandates, specifically FCD1 requirements, demand strict operational timelines during a catastrophe. Nodes must re-establish mission-critical functions within 12 hours and sustain total isolation for up to 30 days. Maintaining a 30-day island mode operation reveals a conflict between hermetic sealing and atmospheric displacement. Generating autonomous power requires running 6 1,000-kilowatt internal diesel generators. The external air intake required to operate these generators prevents the total positive pressure CBRN isolation mandated by the COOP guidelines. This specific aerodynamic vulnerability can be tracked directly to Department of Defense budgetary requests. The 2024 and 2026 military construction estimates dictate an exact $34 million requirement for security operations and pedestrian access facilities at the Raven Rock Mountain Complex under Project 97669. The requirement to breathe external air to power internal servers creates an aerodynamic failure point at the facility's blast doors. Maintaining continuous operations at a site spanning the Pennsylvania and Maryland border requires constant administrative patching. Under 5 CFR Part 532, the Office of Personnel Management published a regulatory redefinition. They moved the Adams County portion of the complex into the Washington-Baltimore-Arlington wage area. This maneuver was executed to eliminate civilian staffing pay disparities and prevent an internal operational collapse. The government can execute administrative patches to maintain its jurisdiction, but it cannot patch the physical properties of the rock mass itself. Deep subterranean defense installations rely on high compressive strength rock to survive atmospheric thermal waves. That same rock mass binds the facility to the propagation laws of internal acoustic resonance. During a kinetic strike, microfaulting in the Blue Ridge Formation acts as high-speed energy conduits, channeling shockwaves directly into the tunnel anchors. The 18-inch internal steel coil springs and lateral rubber dampeners possess an absolute physical tolerance limit against sustained low-frequency acoustic waves. Once kinetic acceleration exceeds this threshold, the structural shearing of internal military command servers is no longer a probability, it is a mathematical certainty.